Welcome to our channel Biswanka's Math Exclusive. This is my part 3 video on Fourier Transform. Start with this example. Find the Fourier Transform of the function fx equals to 1 mod x less than 1 and when mod x greater than equals to 1 then fx equals to 0. Hence find integration 0 to infinity sin x by x dx. Now start the solve. Since fk is the Fourier transform of fx, then fk equals to 1 by root over of twice pi integration minus infinity to infinity fx e to the power ikx dx equals to 1 by root over of twice pi integration minus infinity to infinity fx. We break the limit here, so fx e to the power ikx dx plus integration minus 1 to 1 fx e to the power ikx dx plus integration 1 to infinity fx e to the power ikx dx equals to 1 by root over of twice pi into integration minus 1 to 1 e to the power ikx dx equals to 1 by root over of twice pi e to the power ikx by ik in the limit minus 1 to 1 equals to 1 by root over of twice pi into e to the power ik minus e to the power minus ik by ik equals to 2 by k root over of twice pi sin k, as sin k equals to e to the power ik minus e to the power minus ik by twice I equals to root over of 2 by pi sin k by k. Numbering it equation 1. Now second part. By Fourier transform theorem, we have fx equals to 1 by root over of twice pi integration minus infinity to infinity fk e to the power ikx dk equals to 1 by root over of twice pi integration minus infinity to infinity root over of 2 by pi sin k by k e to the power ikx dk by 1 equals to 1 by pi integration minus infinity to infinity e to the power ikx sin k by k dk. Putting x equals to 0, we get f0 equals to 1 by pi integration minus infinity to infinity sin k by k dk, or 1 equals to 1 by pi integration minus infinity to infinity sin k by k dk, or integration 0 to infinity sin k by k dk equals to pi by 2, as f of minus k equals to f of k. Thus integration 0 to infinity sin x by x dx equals to pi by 2. Proved. Now start the next. Fourier sine and cosine transform. This is the definition. If a function is defined in open interval 0 to infinity, then its Fourier sine transform denoted by fsk and is defined by the integral fsk equals to root over of 2 by pi integration 0 to infinity fx sin kx dx, provided the integral exists. Now mod of integration 0 to infinity fx sin kx dx less than equals to 0 to infinity mod of fx mod of sin kx dx less than equals to integration 0 to infinity mod of fx dx, as sin kx mod of sin kx less than equals to 1. Thus the integral 1 exists if fx is integrable in any subinterval of 0 to infinity, and the integral 0 to infinity integration fx dx be absolutely convergent. Similarly, fck, that is cosine transform, equals to root over of 2 by pi integration 0 to infinity fx cos kx dx, provided the integral exists. Now mod integration 0 to infinity fx cos kx dx less than equals to integration 0 to infinity mod of fx mod of cos kx dx less than equals to integration 0 to infinity mod of fx dx as cos kx mod of cos kx less than equals to 1. Thus the integral to exist if fx integrable in any subinterval of 0 to infinity and the integration 0 to infinity fx dx be absolutely convergent. Now inversion formula for Fourier sine and cosine transform. Sine transform. We now choose a function gx in minus infinity to infinity and is defined as gx equals to fx x greater than equals to 0 and minus f of minus x when x less than 0. If Fourier sine transform of fx exists, then the Fourier transform fk of gx exists and is defined by gk is equal to 1 by root over of 2 pi integration minus infinity to infinity gx e to the power ikx dx equals to 1 by root over of 2 pi integration minus infinity to 0 and minus f of minus x into e to the power ikx dx plus 1 by root over of twice pi integration 0 to infinity fx e to the power ikx dx. For first integral put x equals to minus u equals to 1 by root over of twice pi integration 0 to infinity minus f of u into e to the power ikU du plus 1 by root over of twice pi integration 0 to infinity fx e to the power ikx dx. Now similarly solve. We get I into root over of 2 by pi integration 0 to infinity fx sin kx dx equals to I fs k equals to 1. This is equation 1. So if fx satisfy the Dirichlet conditions in 0 to infinity and integration 0 to infinity mod of fx dx is convergent, then gx must satisfy the sum conditions in minus infinity to infinity and integration minus infinity to infinity mod of gx dx is convergent. By Fourier inversion theorem, we have for x greater than 0 is 1 by 2 into fx plus 0 plus fx minus 0 equals to 1 by root over of twice pi integration minus infinity to infinity g of k e to the power ikx dk equals to 1 by root over of twice pi integration minus infinity to infinity I fs k e to the power ikx dk by 1. Solving and putting k equals to minus y, then also solve step by step. We get root over of 2 by pi integration 0 to infinity fsk sin kx dk. Thus the Fourier inversion formula for Fourier sine transform is this. Again, if fx is continuous, then f of x plus 0 equals to fx equals to fx minus 0. That is half of fx plus fx equals to root over of 2 by pi integration 0 to infinity fsk sin kx dk. Then we get fx equals to root over of 2 by pi integration 0 to infinity fsk sin kx dx. Similarly, we get the cosine transform. Follow the step of sine transform. Follow the step, then we get the Fourier transform of cosine transform. Same as above problem. step by step solve this, and we get fx equals to root over of twice by pi integration 0 to infinity fck cos kx dx. Now Parseval's theorem for sine and cosine transform. Let fx and gx be two functions defined in the interval 0 to infinity, and let their Fourier sine and cosine transform are respectively fsk and gsk, and then fck and gck. Now integration 0 to infinity fck gck cos kx dk, putting the values of this, and then solve, step by step solve, then applying the inversion formula of Fourier cosine transform, we get this. Then putting x equals to 0, then let gx equals to g bar x conjugate complex of gx. Follow the step and solve. This is the Parseval's relation for Fourier cosine transform. So here my today's topic is end. If you find my video is helpful for you, please like, share and subscribe our channel. Thank you.